Hi everyone, very excited to be here. I always enjoy droidCon conferences, both online and offline, but this year is rather online conferences only. And we're here to talk about unit tests and effective use of test doubles. But first of all, let me briefly introduce myself. Most of the time, I work on Android applications at Tango Digital Agency in Kraków, in Poland. Besides that, I do some freelancing work, and I write a blog dedicated to testing with Kotlin and Kotlin-related test tools. My sport activities are focused on volleyball, both beach volleyball and indoor volleyball. And I also play some music. You can hear my work on Spotify if you want to. Links are provided here, aggregated on my social page. Okay, we're here to talk about fundamentals of unit test, the concept of test doubles. And I will share my thoughts about unit tests, especially using test doubles for better and more efficient mocking. Here you can see the test pyramid. This is some kind of graphical representation of how test suite for software projects should be designed. On the top, we have end-to-end tests. In Android case, that would be tests created with Espresso, Appium, or stuff like that. The second stage are integration tests. In this case, in Android, we are testing integration between high-level components. We can use some kind of libraries such as Roboelectric, or write integration test without Android framework directly. And on the bottom of test pyramid, we have unit tests. Tests that are performed in isolation are relatively cheap and should be running fast. Usually, in software projects, there should be much more unit tests than integration or end-to-end tests. So on the bottom, we have more isolation. On the top, we have more integration between components we are testing. And unit tests should be, in theory, cheaper than other kinds of tests. And unit tests and ways of keeping isolation is the main focus of today's presentation. So let's take a look at those puzzles. Those puzzles represent some kind of software system where each puzzle is some system component. As you can see, they are somehow connected. While we are focusing on the class we want to test, we should take care of its direct dependencies marked in yellow. And for the sake of unit tests, we don't care much about other components. So now we can break it down a little. We have our class, which we will be calling system under test. And we have other components that are direct dependencies of system under test, and they should be usually passed by constructor. We won't pass the whole dependency, but we will try to somehow provide a test double object which will fit right into particular puzzle in a convenient way. I have Android background, and I believe most of listeners here are Android developers. So I will try to present test doubles in Android context in an Android way. In mobile applications, we usually have some kind of splash screen, which is displayed right after app is opened by the user. In this place, we can decide if user should be redirected to the main screen of the app or show him logic screen. Maybe include some permission check or stuff like that. And splash screen dependencies are hidden behind interfaces. We have router, which would be responsible for opening given screens. We have interface for view, such as activity or fragment, where we would display loading or trigger error message. And we have some kind of use case which will tell us if user is actually logged into our app or not. And in the end, we have also some kind of tracking ID, which could be some string representing advertising campaign from Google Store or other analytical property, which should be a simple value in here. So what should we test? Of course, we should test stuff like displaying loading indicator, routing to proper places in app, and displaying error if something goes wrong. So if we take a look at the puzzle once again, our system under test would be splash screen presenter. And other components would be fitting right into him, just like the puzzles. And we will try to provide test doubles to have splash screen presenter tested in isolation. Okay, first dependency of splash screen presenter. Splash router. Real implementation would start activity, change something on fragment manager, or even trigger some action on navigation component. In test double, we would like to know if a given function was invoked, so we could perform assertion on that. We will need some kind of verificator, something that will allow us to record splash router invocations, so we could perform assertion. Other dependency, view. Android implementation would rely on layout in XML. It would be changing visibility of some loading indicator or trigger snack bar event in fragment or activity. But in unit test, we cannot mock the whole activity or fragment in a convenient way. So in here, we would provide test double, some kind of object that will store information about state of the screen or record information that given function was invoked. The next dependency, use case, resolving if user is logged in or logged out. This class in real implementation would check if user exists in local database or will check some kind of token validity. Then we'll reduce this information to enum class representing user state if it's logged in or logged out. In our fake implementation, we will just return given enum values or throw exception to simulate real behavior. And finally, we have tracking ID. While in a real application, that string would be passed from external applications such as Play Store. Here, we can directly provide fake value for unit test. So now would be good moment to distinguish some kinds of test doubles. We have stub, test double which will return predefined value. We have fake, which will act as lightweight implementation. We have mock, special object that would be storing information about its interactions. And finally, dummy value, some property we pass to unit test just to satisfy compiler, but we don't take it under consideration. But it's good to remember that we often refer to all test doubles as mocks. So now let's see how we can create mocks for each dependency in our Splash presenter. First of all, we have this resolve user state use case, which is functional interface in Kotlin. In the newest version of language, we don't have to implement object of type resolve user state use case. If this is a fun interface with only one function, we can just pass a value here. And we will pass this value, other value, or throw exception from that method. Next thing. We have our dummy value. We will provide this value even if we don't use it, just to have build passing. And then we have mock. We want to somehow record interactions with Splash router. We can use here mocking framework such as Mockito to verify if given method was invoked. So, given user status checks throws some exception when we are starting this presenter, then we assert that error was displayed. And here you can see this dummy value. We don't use it, but we have to pass it. Okay, so we have mock verify defined here with Mockito, and we have other test case using Mockito verify. Once again, we are stubbing resolve user state use case. We return just value logged in. We start the presenter, and then we verify that open main screen was invoked on the router. Mockito makes it very easy to verify function invocations. And of course, there is opposite case. When user is logged out, we expect to open the login screen on router, and in a very convenient way, we can achieve that test behavior with Mockito. We can also provide mock for view. In case of exception thrown by resolve user state use case, we want to display error on view, and thanks to Mockito, we can perform that kind of verification too. This stub throws error, and then with Mockito we verify that display error was invoked on view, and this view is created with Mockito mock function. Okay, but we are not bound to mocking frameworks. We can just provide our lightweight implementation ourselves. Good example would be here the view of the splash screen. Somewhere in the test directory, we create implementation of that view interface, and it will keep the state of loading indicator and record information that error was displayed. So in that case, when in our test we throw exception and display error is invoked on view, we simply check if our fake object state was changed. And instead of using Mockito for verification, we perform simple assertion with assertion library of our choice. Once again, stub throws error, and then we perform assertion on fake object. Okay, so what are effective differences between mock using framework and custom built fake? Mock can be created for us by frameworks such as Mockito or Mock-K. but the framework is controlling this object behavior and its life cycle. For more complex checks with mocks, with library for mocking like mockit or mock-k, you can use matchers to, for example, verify how many times given function was invoked and if was invoked with proper arguments. Fake, in the other hand, has to be implemented by developer. In non-complex cases, such as splash screen view, it's just implementing a few methods in interface and adding some Boolean properties. You are in full control here. You can decide how this fake should behave, and effectively you can reduce complex verification to simple assertions, as shown in example before. But of course, when you are writing a fake object, you are introducing some logic to test the directory, and maybe you should test that too. I don't know, it's up to developer. One of the most popular mocking frameworks in JVM and in Android general is Mockito. Mockito allows creating mocks in a simple way, even in one line. I will present you also usage of Mockito with Mockito Kotlin extensions. Let's consider another screen with a model view presenter architecture. We have some view which will display list of items, display one item, or render error. We have also data provider, some kind of data source, such as database described by interface with two methods, get all elements or get one element by ID. And we will use Mockito to create stub for data provider and create mock for view. So let's just jump straight into first test case. We want to verify that if data provider returns non-empty list of elements, that all items are displayed on view. So first, we create mock for view, then create mock for data provider. And this notation in here, in stubbed Mockito method, means that every getAll method invocation will always return this given list of elements. And then we are starting presenter and we are using Mockito function verify to check that display items on view was invoked with that particular list of elements. That was pretty straightforward example, so let's do something else. Another test case could be verification of displaying only one element. So here we will stub another method of data provider, getOne. And we write that on getOne with any parameter, it should return given element defined before. Any here is example of matcher. This method would be stubbed for all possible invocations excluding null values in Kotlin. So on every possible argument passed to getOne, this mock will return that given element defined before. And then we can proceed with regular verification on view. With Mockito, we verify that display details function was invoked with given element that was returned by our mocked data provider. And of course, we can introduce a more complex matcher if we need to. Let's suppose that we want to return the same element for function invocations where ID is between 0 and 5. And we can use Mockito matcher arg.dat for that case. In Lambda, we write Boolean expression, some predicate, and while performing stubbing, Mockito will check that Boolean expression and return given element for elements matching this expression, and for function invocations with argument greater than 5, it will throw exception. And matchers can be used for verifications too. In this example, we can use similar matcher in assertion and make the test pass for each argument that matches that given expression. In Mockito, there are a lot of matchers, but I usually use arg.dat and EQ. But that's not all that Mockito can do for us. We can perform assertions on verifications with it. Now we are testing in here a path where the data provider returns null instead of valid element. And then we want to verify that error was displayed on view, and additionally that display details was never invoked with any arguments. Of course, all of those things could be achieved without using Mockito. For every test case, we can provide our own lightweight implementation and create custom fakes. That may be convenient when we are not sure how Mockito matcher work or which matcher we should use in here, or we would really need to stretch those mocks very hard to mimic behavior we want to achieve. And in general, there is no silver bullet for creating test doubles. Every test case is special in its own way. Mockito is Java framework, and coroutines are Kotlin concept built into the language. And Java coroutine integration, unfortunately, is not straightforward. So when we will try to mock suspend function with Mockito, test code simply won't compile. And we can, of course, try to use some generic mechanism of Mockito, use some do-answer construct, but in that way we'll lose readability of Mockito Kotlin DSL. But there is another framework for mocking we can use, and it's mock-k. Kotlin first library with similar DSL style stubbing mechanism and with coroutine support in a convenient way. There is method we can use every get data returns 1 to 3, and for suspend function we can write co every from coroutine every. So the stubbing mechanism should be easier for suspend function while using mock-k. But of course, there is other solution for mocking suspend functions or providing fakes. We can just create lightweight implementation instead of relying on the framework. So every suspended invocation of getData will return something predefined passed to our fake via constructor. And it's up to developer if he likes to use more complex functions from mocking framework, or maybe create fakes by on his own. Static properties. Static properties in Java and in JVM libraries are very common. Some developers love to use static constructs, while others are criticizing it. That's not for me to tell if static access is good or bad. It's a tool, it exists, and I will show you a few approaches to handle static access in test code. But first of all, let's check again our puzzles with system under test and its dependencies. While other dependencies are injected through the constructor, static objects may not be direct dependency of system under test. In a way, they are part of it, and they are kinda outside, so it's very special case. So first approach to handle static access in test would be to remove static access and provide wrapper function for that code. Let's suppose that we are using Yoda time in our system under test, and we would like to change behavior of datetime.now function. So if you need to change behavior of that property in test, you could just use extra interface or facade to abstract it away, inject it to your system under test, and life goes on. Other case that developers that are using RxJava may be familiar with would be abstracting away every scheduler we need to use in our system under test, such as main scheduler for Android or IO and background schedulers if we are using some threading in our code, but we would like to execute our test in a synchronous way. Okay, other approach to mock static methods would be to set static properties globally. Sometimes some static methods are invoked under the hood, just like it happens in live data. And some kind of approach to solve that problem of live data using Android main thread under the hood could be delegating main thread executor in our test and setting its value before we execute our test suite, and setting this delegate to null after we execute all the test. And remember, do things like this only if you have no control over the static access in a library you use or you have to use. And of course, for other cases, there is library for that. Mock-K actually allows us to mock static things. For one of my pseudo-integration tests for data binding, I used Mock-K to mock Android looper, just to not have crashing code. So summary, how to approach testing static things. If you can remove static keywords and then rewrite particular piece of code, that's great. But if that's not possible and you have to use those static things in your unit test, try to at least create provider or wrapper some kind of little abstraction. If it fails, check if you could set something globally, just like this thread executor for live data. I believe you can set globally date time for unit test and things like that. And if other things fails, try to use mocking framework to do the hard work for you. You can use mock-K or PowerMock. There are plenty tools to achieve that behavior. And of course, if you are brave enough, you can try to use reflection to modify existing properties and then use static objects in your test directly. And if you are using some library that is well documented and developers actually care about its existence, there may be library with test extensions to handle that stuff. Okay, to sum things up, we talked about fundamental concepts of unit testing, test doubles. And in the end, I will give few takeaways. Know your test structure. With given when then flow, you will find creating test doubles much easier. In the given section, prepare dependencies for your system under test. In a when section, execute logic you want to test, and in the end, in assert section, in then section, verify that your system acts just like you want. Compare your results to what was generated by the system and what you expect those properties to be. Know when to use proper test double. Sometimes you need to pass only stubbed value or write simple fake. You don't need Mockito for everything. Using Mockito or Mock-K just to return predefined value could be overkill for your system when you have very big test suite. Creation of these objects may be very expensive in terms of CPU or memory usage. And sometimes it could be easier and more efficient to write fake implementation by yourself. And last but not least, keep good separation of concerns, or at least try to use constructor injection. It's not impossible to provide fakes for static variables and objects, but every test case is special in its very own way. Readability comes first. And if your code is solid and follow, in general, dependency inversion principle, then you are good to go with writing great test suites that will serve you, your team, and your project as well. So thank you for your attention. That's all from me today. I hope that you enjoyed my presentation. For more unit testing related content, check my blog, kotlintesting.com. And if you want to find me online, go to the link you saw on the screen. There are my social profiles. So now I believe we have some time for Q&A. Okay, I see first question. Can you explain what coroutine scope is in layman's term? Unfortunately, I cannot answer that question. I'm not a coroutine expert. I usually use Eric's Java in my projects, and coroutines are only coming to me just to use in the future projects. Another question. Are there any performance impacts of Mock-K? Well, I didn't measure it by myself, but I remember reading some article on Medium, so I believe you could find answer to your question there. And the last question I see on the screen, what are the other use cases of mock-K? Most of the presentation was dedicated to Mockito Kotlin, Mockito with Mockito Kotlin extensions. And in general, you can use mock-K just like you were using Mockito and Mockito Kotlin before. Every function for basic mocking is in here. In addition, mock-K supports mocking final classes. I believe that in regular Mockito, to enable mocking final classes, and I will just tell that classes in Kotlin are final by default, unless you specify that class is open or abstract, of course. And with Mockito, you had to enable special plugin to be able to mock final classes. In mock-K, it's enabled by default. Okay, another question. Is mock-K better option than Mockito? Does these test tools have any impact when we're talking about Java or Kotlin language? So the greatest thing about mock-K is that it's Kotlin first. We can, just like I showed you before, mock coroutines in a very convenient way in a one-liner. We have these DSL constructs to create mocks and stubs. Syntax is slightly different. And of course, the biggest difference between Mockito and mock-K, it's this DSL for creating stubs and mocks. Remember that Mockito is a Java tool, but we have Mockito Kotlin extensions. And in a legacy project where someone was using regular Mockito and we are writing Kotlin code, I would just add Mockito Kotlin extensions. But when I would start new projects, I will go with mock-K from the very beginning. Okay, I think that's all you wanted to ask me now. So thank you once again for attention. I hope that you enjoyed this presentation, that you learned something new. And of course, you can find me online. My social profiles should be linked somewhere. Thanks again for hosting me, droidCon, and see you soon.